Hello. So, good evening to all of you. We are going to talk about two sample hypothesis testing. And so, before starting this, we must understand that data before making any decision or before trying any test. We need to understand the nature of the data. So, in this, we have two sample. They can be totally different groups. They are totally independent of each other, or paired sample test. So paired sample means two different situation of the same event. So we are going to talk about these two things. Two different population, two different groups, that is called independent samples and paired samples. So paired sample, let's say basically in health, a medicine or drug trial, if what is the blood pressure before prescribing any medicine, what is the blood pressure of the patient after prescribing the medicine. So before before and after, similarly, what is the salary before MBA, what is the salary after MBA. So you can understand the impact of MBA in terms of, so basically that is called paired sample. When you understand this kind of situation, you use paired sample test because both the tests are there. Independent means two different situations, two different data set. So based on that, and two sample hypothesis testing that we are going to cover in this, based on mean, based on proportion, and based on the variance, that we already looked into the past, that we compare the mean, we compare the proportion, and we compare the variance or standard deviation. Basically, we are going to look in this module only these two things, mean and proportion. Under mini tab, you can get this option here. You can see okay, here under statistics, basic statistics, here you can see two sample t-test and paired t-test. So when do we use two sample t-test? When you are having two independent set of sample, and paired when you have the same situation before, after, or based on the same thing. Here you can also do the two proportions and two variance. So this is, and this PDF slide you can get at the end of the module. So this is shared at the end of the module. In the bottom of the module, you can see, and here you can see two proportion, two variance, two sample t-test, paired sample. So before using these things, you need to understand the which is going to be required based on data and based on the question demand. So these are the steps to test the hypothesis. Identify the test which is going to be useful. Two sample T or paired sample. So basically it's null hypothesis. You need to carefully understand what is the requirement of null and alternative hypothesis. What is null hypothesis? Make sure that mu1 is first sample, mu2 is second sample, and what is
watermelon, but it's not watermelon, black cherry.
I would request you to kindly mute your microphone, please.
Thanks, bye.
Okay, so null, sorry. Here, if you are going to check the two based on a mean, you need to check whether it's equal variance or unequal variance. And that test is based on the ANOVA. We will show you. First thing, to draw or to frame null and alternative hypothesis. What is null hypothesis? So let me explain here. And so null means nothing. The meaning is null is equal to 0 or nothing. So what it says, if you have two sample 1, I would say sample 1 or sample 2 and sample 2. So based on sample 1 and sample 2, the mu is corresponding population. So mu1 is a mean. As you know the notation, mu2 is second. So mu1 minus mu1 minus mu2 equal to 0. 0 means null. Means there is no difference between mean of first sample and mean of second, or corresponding population. So this is what is null hypothesis. Alternative says this is not 0. Something is useful. So similarly, it could be mu1 minus mu2 is less than equal to 0. Alternative says mu1 minus mu2 is greater than. So basically you see in null hypothesis, two symbols are there together here. Two symbols are there. Where? Where alternative has only one symbol. So equal or less than, equal or greater than. So basically, I think I did a mistake. One has to be less, one has to be, sorry, I don't know why my cursor is keep writing. So less than equal to, greater than equal to. Here, greater than or less than. So, question, if not given, always use 0.05 alpha, and confidence interval is 95%, then alpha is 5%. If confidence is 90, then alpha is 10%. If alpha is 10%, confidence interval is 90%. So Minitab accept the confidence interval. So basically, always look into this. Calculate the test statistics p-value using Minitab. So if you have data provided with the question, reject null hypothesis. This is the very important rule, p-value rule. If p-value is less than alpha value, p-value, reject null hypothesis. Or, in other words, if p-value is greater than, technically we fail to reject null hypothesis. But, in simple word, I would say, accept null hypothesis. So basically, this is the rule of thumb in entire statistics. So always keep in mind, but you must understand what is the null and alternative hypothesis corresponding. It can be also decided based on T or Z test or Z value, and write your managerial implication of the hypothesis, take actions based on the decision. So this is the process or steps in order to do hypothesis testing. Now let's start some, let me do some Minitab thing, and then Okay, so I start, this is Minitab. And I think very first example is international and domestic. Here you go. I'm just, so always remember, understand this data. Can you see my Minitab? Is Minitab visible to everyone?
Yeah. Yeah.
Yes.
Yes.
Perfect.
Did
So
you
look
enter
into-
this data yourself from the problem sets, or were you able to port this over?
Okay, so
problem sets.
this is basically I just got from the book,
Okay.
and this data set is right in the, you know, at the bottom of the module is shared. So I can show you also that. So let me show you then. So here you see the, actually I always prefer you to follow the course, then go under module, and under module you will find, you know, the lecture, the MCQ. Some people just directly go into the assignment. Here you can see the recorded previous lecture. This is PDF I'm sharing, and this is the data set belong to book, which is shared here. So in case you want to play with the data set, you can do that. Okay.
Thank you.
So I just, you know, this is, so basically, what do you see from here? The hypothesis testing for proportion or mean, it depends on, it should not be the same. Like, you know, it should not be 15 sample. It should not be any sample in one sample, any sample in two sample. Mean the n can be anything. So here 10, here we took 15. Or because the hypothesis testing, here we use mean and standard deviation and sample size. So mean, standard deviation, and sample size. So doesn't matter, that has to be equal. Okay, so this is international flight and their baggage weight. This is domestic flight and their baggage weight. Now I would like to check whether, so these are the two independent samples, separate. I would like to check whether there's a difference in the international or domestic baggage weight or not. So I go under statistics, basic, two sample, T. And here, if you have sample one, sample two, so basically you make sure which one is your sample one and sample two. So I just selected sample one is this, and this is, so international minus domestic. Each sample is column. You can also put the summarized data. That means what is the sample size? I can say here 10 sample size. What is the mean? So whatever is the mean of these 10 bags, I will put here. Whatever is the standard deviation based on 10, I can put this. Similarly, I can do the sample 2 is 15 sample size, and mean, whatever mean or average, whatever standard deviation I can get. So this is the summarized way of doing, and this is based on the data. And now we have the option. Difference. So first thing, by default, it is coming 95. You can change sample one mean minus sample two mean. So clearly see. So difference is 0, means there's no difference. Alternative hypothesis. And you know, this gives you the alternative option. It doesn't give you null option. Null hypothesis, it always, Minitab always gives you alternative. Now come to the this option. When do we assume equal variance? When do we assume unequal variance? We will talk about this later. So assume or not assume. So I'm not assuming as of now, but we can check. Sorry, here, yeah, okay. And graph we don't need. And now, okay. So this is T-value is 3.16, degree of freedom 10, and P-value is how much? What percent? 1%. And we are checking the hypothesis as 5% level of significance. P-value is coming 1%. What we can conclude? We can conclude simply that null hypothesis. What is the null hypothesis? Null hypothesis says, let me go back. Null hypothesis says there's no difference. So if p-value here, p-value is greater than alpha, sorry, p-value is less than alpha. So we have p-value is 1% and alpha is 5%. Reject null hypothesis and accept alternative hypothesis. What is the meaning of that? Alternative, there's mu1 minus mu2 is not equal to 0, means there is a difference in both samples. Difference in mean of the samples. Or there's a difference in international baggage weight and domestic weight. So this is clear indication. So please remember this. If suppose this p-value is greater than alpha, let's say we get p-value is 6%, then we can say the baggage weight is almost similar of international flight and domestic flight. Now, so this is same situation. So you can see. So clearly, I mean, I just explained in detail, don't. So basically this is, don't follow this rule, because this I used to follow when we did not have computer and calculator. So now we have more sophisticated tools. So please follow the tools that we have. Null hypothesis this, alternative hypothesis this, 95%, alpha is 5%, test, and we get this. P-value is 1%, so hypothesis is rejected. And we conclude there is a difference between mean weight of international bags or international flights bag and domestic flight bags. Now, let's go further. Now, very first thing, please, I mean, again, I'm saying because we used to do standard deviation of 1 divided by standard. If that is less than 2, we used to assume equal variance. But, you know, please don't follow this. I just made the slide based on my own experience. So again, I'm saying don't use. Go through the technical thing, which is given in the book. First thing is eyeball test. You know how you can check whether equal variance or not equal variance? First, you do the box plot of both the thing. And we can clearly see in the box plot, there's a variance. They are not equal variance, because you can see this is basically, you know, concentration is varying here to here. This is here to here. And this is, so basically, you can clearly see there is a clear, they are not equal. Both variation is looking different. Now, second thing is this. We can do this using, okay, so again, I'm saying don't follow this. Okay, now go here. The another one, next step. So this is another, you know, proper technical way. First, to eyeball test. Through eyeball, you can see how the box plot is behaving both. And you can, if there's overlapping and you are not able to decide which one is correct, then use this option. under, statistics, ANOVA test for equal variance and consider normal distribution only. So we spoke about, this in past class about normality and everything. So let me go under mini tab. Statistics, ANOVA, test for equal variance. And test for equal, consider only if normal. So basically you have to check both sample if you have large sample, and if you see the normality condition, how you can see the normality if they are behaving, and I will show you later, just a minute. So F test in case of normality, Levin test without normality assumption. And again, here p-value is less than alpha, we cannot assume equal variance. If p-value, so let's go. So here use based on normal distribution, we are not checking. And okay. So you can clearly see here, this is 2%. So multiple comparison p-value is coming 0.12 and this is coming 0.23. So if you look, 0.023 means 2.3% and 1, which is less than 5%. That means we can say we cannot assume equal variance. And if you see the p-value is greater than the alpha value, you can consider. So make sure before doing this, you can always check the equal or unequal variance option. So most important for null and the Minitab has the option of alternative hypothesis. I already explained. And you see, this is the case of paired sample where, this is, these are the 12 people, 12 samples, and after and before. So after, before this was the situation, after this is the situation of is weight loss differ significantly after workout. And so this is paired t-test. The process is same, but you have to use different because there's different equation, different formula, and exactly the same process for proportion. Null hypothesis proportion 1 minus proportion 2 equal to 0, and so on and so forth. Similarly, so exactly the same process. Here proportion, z value. Here you have two options. So two sample proportion, we reject, you check which one is going to be useful. If you are estimating the proportion separately or pooled. So basically, very simple questions are given when you get this number of events. I can show you here. So statistics, basic statistics, two sample proportion. And here each sample in its own column, like you have here, proportion yes, no, yes, no. Similarly, success, failure, or you can do the summarized events.
So the summarized events would be the one where like it said, I think there was like a problem in the list about Or I struggled with it. There was a problem in the list about
Yeah, 14
vehicles
success.
or something.
Yeah, 14 success out of 95 sample or like,
Yes.
you know,
No, it was
that
like
kind-
Flying More Academy is like 70 of 140 graduates on one and 104 of 260 graduates on another. That would be
okay.
how I'd solve this one, right?
Yeah,
Would be
so
this method.
yeah, just just a minute. Can you repeat it again? So I can put here. So
The summarized data. Okay.
yeah, tell me.
So the number, I was trying to do this problem earlier. This one was 70 of 140 graduates and Fly More Academy,
70 and 140 graduates. Okay, what about the second?
104 and 260.
104, 260.
Yeah.
And okay, so this is, two sample. Sorry,
Yeah,
two
okay.
proportion. And now you have the option 95% summarized difference. If there is, it is not more than 10% or whatever.
Mhm.
And, again, it's equal or not equal difference, not less than, greater than. You have to understand what is the demand. And I'm going to talk about this in just few moments. Estimate the properties separately, use the pooled estimate of the population. If the same population you see, if two different proportion are taken from the same population or separate population, let's say, from the same groups, I took two sample. One sample is like 20 something, and then I took another. Are they same? So basically, you can understand what is the same population, pooled estimate of the proportion. And here is the separately estimate. So which one is going to be? So understand from the nature and the difference not equal to this. So let's understand what is the meaning of all these three. So let me put this. Let's say proportion 1. Whatever you are putting in data side, P1 and P2. So here you put proportion 1 and proportion 2. P1 equal to 0. So this is simple, equal or not equal. But if proportion 1 is higher and proportion 2 is less, so if P1 is higher and this is lesser, so what will come? It will come this, because this is higher and this is lower. Second situation, if P1 is smaller and P2 is higher, sorry, P2 is higher, then what will happen? This will be less than 0. So you need to understand what question is demanding. Accordingly, proportion 1 is higher. So please make sure that you need to frame corresponding hypothesis, alternative hypothesis. So here you can see not equal, difference is less than. Difference is less than 0. That means this is alternative. So null hypothesis will be this P1 is greater. In this case, difference is, sorry. Yeah, in this case, this P2 would be higher because we are talking alternative. So null, what would be the null hypothesis? What would be the alternative hypothesis? Look into this. And now you can see Z value based on normal approximation, and P value is more than 5%. And this is another fissure. So in this case, what do you say? They are almost same because P value is greater than alpha value. So basically, null hypothesis is we fail to reject null hypothesis because P value is more than 5%. Therefore, this sample 1 and sample 2 is almost same. Proportion of this.
very helpful. Thank you.
You're welcome. Yeah, now we come to the third part, which is variance or standard deviation, you know. So here is how standard deviation is given. Here it is given standard deviation of 1 and standard deviation of 2 divided equal to 1. So basically, why? Because, you know, standard deviation, so this is okay, so here, you know, you can see this is two-tail test. This is, and if both are same, so sigma 1 and sigma 2, if they are same, then sigma 1 upon sigma 2 would be 1, approximately 1 or 1. So sigma, this is variance related to variance. Now, less than 1, more than 1 depends upon which factor is bigger, which factor is smaller. Means which standard deviation or which variance is bigger or which is smaller. So you need to figure it out which is the right option. So this is simple variance, or, you know, other way you can see the standard deviation, left tail test. Basically, you know, two things are means equal or less than or equal. Here alternative is not equal and greater, so basically opposite of some signing is issue. So please, you know, just check this with the book. And
Professor, just a question. So that is a way to check variance also, is that correct?
yes, you know the difference between variance and standard deviation?
Yes.
Yeah, so basically standard deviation and variance is same, you know, like, you know, standard deviation is denoted by sigma and sigma square is denoted as variance. So yeah, same thing.
Okay, thank you.
Oh, sorry. I have to share screen again. I did wrong click. Okay, so hope you are seeing my things. So this is the same question, and so basically, yeah, this is the same question. The question is based on variance comparison. So null hypothesis is less than equal to. Here, this is asking question. The data is which is more, you know, which sample is highly international flight baggage weight is highly varying or domestic one. So the question is the variance greater for bags on an international flight? Or so basically we are going to check, because sigma 1 is international flight. So this is, and sigma 2 is domestic flight. And let's see. Here we go statistics to variance, and we can select the, so, and we have different options. So here p-value, you know, this is again. So basically we want to see international flight is higher. The variance of international flight is higher. So look into this. Here ratio, if this is greater, then we can prove the alternative hypothesis? Because alternative hypothesis is our main aim if we want to establish any useful meaning of something. Alternative has to be proved, means alpha is a p-value should be less than. So ratio is greater than hypothesized ratio, which is 1. Why? Because if international is bigger and domestic is lower, then the ratio will be greater than 1 only. So if I use this option, normal distribution, what we get here? P-value is, so P-value is less than 5%, and we can clearly see, this international variance of, or standard deviation of variance of international baggage weight is higher than domestic weight. So other option under Minitab that you can select, you can clearly select, choose the hypothesis testing, and you have the option under assistance. Yeah. Here you have hypothesis testing, and now you can select. So you have, where is the two sample? Here you have 2 sample t-test, paired sample t-test, and 2 sample standard deviation. And so basically this is what is hypothesis. So you compare, so basically it is, we are not using this chi-square or this, but defect is proportion. This is proportion, this is standard. So you can use, we are not using chi-square. So just look into this. Okay. So basically the same way you can get the answer. So here you can select the right way and you can get the answer. So this is about module 2. But before going into this, I would like to also briefly explain, if you have more than 2 sample, let's say we are talking about 2. Let's say you have 3 different, sample, or more than 3. What is the way? Then there is a way which is called ANOVA, analysis of variance, and that is used. So basically, that is used here. And so let's say if I copy this, just for knowledge, we don't have an assignment, we don't have for any other purpose. Just for your knowledge, I'm just, okay. Let me enter the random numbers. So calculate random data, integer, $20, minimum value 20, maximum is 50. So let's say we have 3 sample or more than 3, and then we can compare using ANOVA. So here analysis of means and here again, confidence interval, you can select all those things. Box plot is important, which So here you can clearly see our three groups are different. And here, this clearly see from this box plot, this is different from as compared to this and this, but they are coming close, at least one group. So you can see using also p-value. So here you see f value, p value is 0. That means they are different. At least one group is different. And here you can find the p-value, analysis of variance. So if you have more sample and you want to do, then you can get inside the ANOVA and you can understand. But we are just dealing with two in the course. So we are just limiting ourselves to here. And this is about module number 2. If any question, please feel free to ask. If you don't have any question, then I would like to say one. Yeah.
I only had one question, and it was just going through just the multiple choice questions. There's only one that I kind of got stuck on, and then I realized I was doing it backwards. It was for the Z-calc, you have to find the p-value. And it showed a positive, and then I realized I had entered it as a negative when I went to do like calc probability distributions and then normal, and then it is there a reason why was it supposed to be you're supposed to enter it as a negative if it's a positive? Is it like a alternative?
If the z value is negative value, like if
Mhm.
on the other side of on the curve, this is a curve. So basically this is a curve, if you see, and this is like 0. This
Yeah.
side is negative value and this side is positive value. If you are getting this side answer, I mean, you can put negative, let's say z value is coming for you negative 1.24. You can put, minus 1.24 and clearly allowed. However, I don't know what you are doing. So basically, if you have any question related to that, you can send me your process of doing in email and I will check and I will correct and I will
Oh,
see.
gotcha. Yeah,
Because
I noticed when I entered it as a positive, I got the wrong answer. But then if I took it and entered it as a negative, I got the right answer.
Yeah,
It shows in the question it shows a positive, but in order to get the right answer, I had to enter it as a negative.
okay, so please, share me your calculation. I will look into that. What is the actual demand of the question? Basically,
Gotcha.
questions are framed in the calculation is not difficult in the course. Calculation is not difficult, is very easy. You just need to click and get, but the understanding the demand of the question is little tricky, little, you need to think critically 2-3 times before putting the numbers here and before concluding. So calculation is easy, but what is the actual demand? I don't know. And you just share your process. I will look into the question and I will reply to you.
Okay, will do.
If no question, then I would like to say have a wonderful evening, wonderful night, productive week ahead, and we will see next Tuesday, not Wednesday. Only
I
this
have
week.
a question.
Yeah, please.
Yeah, I have a question about the discussion assignment.
Okay.
When you take the two data from two different cities, so we need to go Minitab and do the calculations to do the answers.
So yeah, I mean, if you see, this is like discussion is. Let me show you. So basically, like I said, Zillow or something. You can
Yes.
use Realtor or so. You can pull the numbers of, the sample of 30, 40, 50 or whatever houses. And you can do the calculation. It's easy on Minitab if you can do this calculation, because you need to understand what is correct. Let's say this is my area, and so for example, I probably compare the South Hill versus Liberty Lake, because this South Hill and Liberty Lake, these two areas. So I pick 20 houses, 30 houses in this particular zip code. I will pick 20, 30 houses, and then I will compare whether which is higher in the price, which is lower in the price. So I will do all the things. So I can get direct data from Redfin. I think that you can extract the direct house data from Redfin. And so you just attach the way you want to do, it's all up to you. But my purpose is you just need to do these experiments. In real life, you will come across this situation. So you can attach the data in Excel, and the way you want to calculate and you want to do, please feel free to do.
And do you want something in writing, like 500 words, what I did, why I did?
Yeah, so basically, the hypothesis testing process, how you will frame the hypothesis. Step one, like those 5-6 steps. Steps one, I would say we started discussing the housing prices in Spokane, South Hill, and Liberty. My friend said Liberty Lake housing prices is higher. I said no, South Hill is Spokane. So we started, then we framed the null hypothesis. Spokane housing prices minus Liberty Lake housing prices equal to 0, and then alternative hypothesis. So basically, you are going to frame. Then at the conclusion, when whatever result is coming, let's say Liberty, then you have to justify your results. That's why Liberty Lake is higher, why Spokane South Hill is higher. So not 500, but at least complete process has to have complete this thing. How you collected data, that is data collection. You just excuse me. Data collection that you went on Redif.com. So basically, complete process you need to write in words also. Is it making sense?
To upload something from Minitab?
Yeah, you can upload through Minitab. If I can download and open, perfect.
Okay, thank you.
You're welcome. Okay, then good evening and good night to everyone. Bye-bye. See you next Tuesday.
Thank you.
Thank you.
Bye.
Thank you.
Most welcome. Most welcome.
Thank you.
Most welcome.